Hello students, welcome to aimsindia online classes. This is a chemistry session. Here we are discussing about the classification of elements. In the earlier sessions we have seen different types of classifications, modern periodic table, and we have started discussing about the trending of atomic properties in the modern periodic table. In this session we are going to see about electron affinity and electronegativity properties. What are these properties? How these two are being trending in the modern periodic table? We are going to see in this session. Okay, let us start with electron affinity, which is also known as electron gain enthalpy. Atoms of some elements gain electrons while forming ionic compounds, isn't it? Ionic compounds means the compounds formed by the transfer of electrons between the atoms or elements. So in this ionic bond formation, some elements they gain electrons. An atom is able to gain an electron only when the electron outside the atom is attracted by the nucleus of it. Yes, if the nucleus of that atom attracts the electron from the outside, then only it can accept that electron and hence it becomes negative ion. So this attraction involves the liberation of energy. So in the attraction of electrons by the nucleus, certain amount of energy will be omitted out. By that can attract the electron and hence it takes the electron inside. Now, the electron affinity of an element is defined as the energy liberated when an electron is added to its neutral gaseous atom. So when an electron is added to a neutral gaseous atom, certain amount of energy will be emitted by that atom. That emitted energy is called electron affinity. See here, suppose an electron is given to this atom from incoming electron it is. When this electron is taken by this atom, so this nucleus will attract this electron. In this attraction, certain amount of energy will be emitted by this atom. That emitted energy by this atom in taking this electron is called electron affinity, which is also known as electron gain enthalpy. So this can be mathematically represented like this. Suppose X is an neutral gaseous atom. To this, if an electron is added, this E represents electron. If it is added, it becomes negative ion. While taking this electron, the atom will release certain amount of energy, which we consider as electron affinity. Okay, it can be defined as now the amount of energy liberated when an electron is added to a neutral gaseous atom is called electron affinity. Like the second and higher ionization energies or ionization potentials, second and third electron gain enthalpies are also possible. However, the addition of a second electron to a monovalent ions as to make it A2 minus is difficult because both have same nuclear charge and A minus requires energy to overcome the force of attractions. So just like the ionization potential, electron affinity also exists in different stages. First electron affinity, second electron affinity, third, fourth, and so on. But here, for the acceptance of the second and third and higher electrons, certain amount of energy is required by that atom. Why? Because nuclear charge is maintained same. It is not being changed. But as extra electrons are being added, negative charge increases. So because of this, nuclear force of attraction on the incoming electrons decreases. So to hold these electrons all together, to reduce the repulsions between the electrons, it requires a certain amount of energy by the atom. So the second electron gain enthalpy is therefore an endothermic process and will be given a positive sign. So just like the instead of being like a first electron affinity, second electron affinity is endothermic. Second and higher electron affinities are endothermic. That means as in the first electron affinity, certain amount of energy is released by the atom while gaining electron. But while gaining the second and third, fourth, and higher electrons, atoms they need energy instead of releasing. That is why we say second and higher electron affinities are endothermic, whereas first electron affinity is exothermic. So if it is exothermic process in the mathematical equation, chemical equations, that energy is represented with a negative sign. If that is endothermic process, then it is denoted with positive sign. Say here mathematically. So similarly, higher electron gain enthalpies are also positive. That means they are also endothermic in process. For example, when an electron is added to oxygen atom to form O minus ion, then immediately oxygen atom releases certain amount of energy. So we can say this is a first electron affinity and it is exothermic as energy released out. However, when second electron is added to O minus ion, so for the already formed O minus ion, if one more electron, that is second electron if it is given, then in the formation of O2 minus ion, energy is absorbed instead of releasing out. So we say second electron affinity is endothermic. That can be mathematically, equationally, it can be represented like this. See. So first electron affinity is represented like this. Oxygen atom is added with one electron and formed O minus ion. There, certain amount of energy is released. That released energy is represented with the negative symbol. Okay, that is exothermic reaction it represents. Whereas if the second electron is given to that O minus ion, so while taking that second electron, oxygen absorbs certain amount of energy from the surroundings instead of releasing. So this amount of energy is taken by oxygen while taking second electron. So we say it is endothermic process. That is why it is shown with the positive symbol. Okay. So variation of this electron affinity in the groups and periods. How does it vary? Let us see here. In a period, as atomic size decreases and nuclear charge increases in a period from left to right, the electron affinity values generally increases because electron affinity means an amount of energy released while gaining electron. The atom with greater nuclear charge can attract the outer electron very easily and hence it releases maximum amount of energy out. The atom with a smaller size will be having greater electron affinity. We know in a period from left to right, size decreases and hence we can say electron affinity gradually generally increases. In any given period, halogen has the highest electron affinity value and the inert gas has a complete valence shell and so does not accept electrons. Therefore, we say electron affinity values for noble gases is considered as 0. So we are telling in a period electron affinity increases from left to right because size decreasing. That means from alkali metals to till halogens means that from first column to 17th column gradually electron affinity increases. But by coming to noble gases means they have already stable configuration. They do not accept any electrons. So there is no question of releasing energy. So we can say IO electron affinity or electron gain enthalpy for noble gases it is considered as 0. So in the periodic table from alkali metals to halogens gradually it increases. That means halogen is having greatest electron affinity in any period and alkali metals are having the lowest. Okay. Next, in a group the electron affinity gradually decreases from top to bottom in a group due to steady increase in the atomic radius of the atoms. And at the same time, nuclear charge also decreases on the outermost electrons. We can consider any group. In a group from top to bottom, what happens? Size increases. As size increases, nuclear charge or nuclear force of attraction on the outer electrons or nuclear charge on the outer electrons decreases. Hence, electron affinity decreases in a group. The electron gain enthalpies of oxygen and fluorine, the members of second period, have less values than the elements sulfur and chlorine of the third period. So we are telling here electron affinity in a group from top to bottom decreases. But if you observe here for the seventh group elements, that is halogens, fluorine, chlorine, bromine and iodine, from fluorine it increased to chlorine and then decreased till iodine and acetylene. So here the second period element fluorine is having lower electron affinity than third period element chlorine. This is because of the small size of fluorine anyhow. In the same way, among the sixth period elements, oxygen, sulfur, selenium, tellurium and polonium, out of these elements also, instead of gradually decreasing from top to oxygen to polonium, first from oxygen to sulfur it increases. Sulfur has greater electron affinity than oxygen. After sulfur again gradually decreases down. Okay. This is due to the small size of atoms of the second period. Because out of fluorine, chlorine, bromine and iodine, fluorine is having the very small size. So that is why while taking an electron inside, certain amount of energy is consumed by fluorine atom to control these electrons, to overcome the repulsions between the electrons as it has very small size. That is why the amount of energy released by fluorine while taking electron will be less than the expected. But in the case of chlorine, what happens? Its size is much bigger. It has a third shell. It has only 7 electrons. It can accommodate more 10 electrons, isn't it? So there is no question of repulsions between them. That's why from fluorine to chlorine it increases. Then after chlorine to down the group it decreases. In the same way, among the sixth group elements also, if you observe, oxygen is having lower electron affinity than sulfur. Fluorine is having lower electron affinity than chlorine. This is because of smaller size of these atoms, oxygen and fluorine. So here the negative symbol represents the evolution of energy, as these are exothermic processes, that is represented with negative symbol. Energy is mentioned with negative symbol. That represents that energy is released out. Okay. And out of all the elements in the periodic table, chlorine is having the greatest or highest electron affinity. We are telling from left to right, electron affinity increases in a period till halogens. So halogens are having now highest electron affinity. That is fluorine, chlorine, bromine, iodine. These are the elements with the highest electron affinity in all the periods. Now, among these also, from top to bottom, electron affinity decreases, we told. But here from fluorine to chlorine, it increases. So now, chlorine is the element with the highest electron affinity among all. Okay. Next, next property of elements is electronegativity. The ionization energy and the electron gain enthalpy are the properties of the isolated atoms of the elements. There has been a need to have a comparative scale relating the abilities of the elements to attract electrons when their atoms are combined. So to compare the relative abilities of these elements, it is needed a comparative scale to compare to observe the properties or abilities of the elements in the combining characteristics. So for this purpose, the concept of electronegativity is introduced. The electronegativity of an element is defined as the relative tendency of its atom to attract electrons towards itself when it is bonded to the atom of another element. So to say simply, the tendency of an element to attract the shared pair of electrons towards it in the bonded molecule is called electronegativity of an element. So remember here, it is just the tendency or behavior of an element to attract the electron pair towards it. It is not the energy. Whereas ionization energy and electron gain enthalpy, These two are energies. One it is required energy by the atoms, one it is released by the atoms. These two are energies. Whereas electronegativity is the tendency of the elements by which they can attract the pair of electrons towards them. Okay. All the factors that influence the ionization energy and electron affinity of elements influence the electron negativity values also for those elements. Because of this, Mulligan proposed that the electronegativity of an element is the average value of ionization energy and electron affinity. So it can be represented mathematically like this. Electronegativity is equal to the average of ionization energy and electron affinity. Okay, if the electronegativity and electron affinity and ionization energy are known, then its electronegativity can be calculated by using this formula. So variation of this electronegativity in the groups and periods, let us see here. How does it vary? First, let us see in a period. Electronegativity increases along a period from left to right. This is due to the increase in the nuclear charge and decrease in the atomic size. Okay, as atomic size decreases, the attracting or the tendency of attracting pair of electrons increases, hence electronegativity increases. That's why if you observe here, third period elements are mentioned from sodium to chlorine. Gradually electronegativity increased. Why? Because size of these atoms slowly decreases from sodium to chlorine. As size decreases and nuclear charge increases, as greater nuclear charge is present, that can pull that shared pair of electrons towards it much more. The tendency of pulling the shared pair of electrons is called electronegativity. So we can say electronegativity is inversely proportional to size of the atoms. Hence, in a period from left to right, it increases. And in case of group, in a group from top to bottom, electronegativity decreases. This also we can say the reason is it is irrational to or inversely proportional to atomic size or atomic radius. We know in a group from top to bottom, size gradually increases. As size increases, attracting power or the tendency of pulling electrons decreases. Hence, electronegativity in a group from top to bottom decreases. We can say an example here. See for the first group elements, lithium, sodium, potassium, rubidium and cesium. These are first group elements from top to bottom. We know from lithium to cesium, atomic size gradually increases. Hence, the tendency of pulling electrons decreases. We can see here gradually electronegativity values decreased, isn't it? And if you see halogen group, fluorine, chlorine, bromine, iodine and astatine. Here also from fluorine to astatine, atomic size gradually decreases. Sorry, increases. Atomic size increases. So the tendency of pulling electron pair towards it decreases. That means from fluorine to astatine, electronegativity decreases as size increasing. Not only in this, in all the groups from top to bottom, electronegativity decreases. So now we are telling in a period, suppose this is periodic table discussion. In a period, it is increasing. So right side elements are having greater electronegativity. Out of these also from top to bottom, electronegativity decreasing. So the topmost element will be having greater electron affinity. That is fluorine. Fluorine is the element with the highest electronegativity. Okay. Next, metallic and non-metallic characteristics or properties. Metals generally show less electronegative character. In compounds, they generally show a tendency to remain positive. That means they will try to lose the electrons, not to attract the electrons. So we can say they do not have much electronegativity. This property is often termed as electropositive character. That means quite opposite to electronegative, we can say. Electronegativity means the tendency of pulling the electrons towards it. but this character is less for metals. They have, in fact, the tendency to lose electrons and form positive ions. This tendency of losing electrons is called electropositive character. Metals are electropositive elements too, you can say, because they will be always ready to lose the electrons and hence they will ready to form positive ions. So we can say metals are electropositive elements. Whereas non-metals are generally more electronegative due to their smaller atomic radii. So always non-metals they'll try to attract or accept the electrons towards them because of their smaller size. This tendency is called electronegativity. So non-metals are electronegative whereas metals are electropositive. Let us examine this by taking one example, third period elements. We know third period elements are sodium, magnesium, aluminum, silicon, phosphorus, sulfur and chlorine. Of course, the last one is noble gas. We need not to bother about it because it has no electronegativity because it is purely about bonded elements. We know noble gases, they do not participate in the bonding. No need to discuss about them. Now, we know that sodium and magnesium are metals, isn't it? So, in this third period, these two are metals. Even aluminum also will come under metal, but it shows some non-metallic properties also. So, that's why it is considered here semi-metallic. And we know these three, phosphorus, sulfur, chlorine, these are non-metals. So, we find metals on left side and non-metals on the right side of the periodic table. Not only in this period, if you observe remaining periods also, mostly at the left hand side there are metals and at the right hand side non-metals are there in the periodic table. This means metallic character decreases in a period from left to right while non-metallic character increases as we move along a period, that is from left to right, isn't it? Next, let us consider one more group, that is a 14th group or 4th A group, carbon family you can say, that contains elements like carbon, silicon, germanium, tin and lead. Now we are going to see in A group how it is. Carbon, silicon, germanium, tin and lead. These are 4th group elements or carbon family you can say. Here also we know that carbon is a non-metal, isn't it? It is a non-metal. Silicon, germanium are metalloids. Hope you know what are metalloids. The elements which can exhibit the properties of both metals and non-metals are called metalloids. Now, tin and lead. These are metals. So, we find the non-metals particularly at the right hand side top and metals at the left hand side and right hand side bottom of the periodic table also. This means metallic character increases while non-metallic character decreases in a group from top to bottom. So we have derived here 2 points. Metallic character in a period from left to right decreases and from top to bottom increases. Whereas non-metallic character from left to right increases in a period and from top to bottom decreases in a group. Okay, that's about metallic and non-metallic character. Okay. So we can see here the summarization of periodic properties of the elements. Ionization energy. First, we have to consider this atomic radius because the remaining all properties are correlated with atomic radius. We can correlate, we can compare them based upon the atomic size of the elements, isn't it? Okay, this is about trending of atomic properties in the modern periodic table. Thank you for watching our video. Please subscribe our YouTube channel Aims Today for latest updates on recorded videos.